On a brisk winter morning in early 2045, in a modest yet cutting-edge laboratory tucked away on the outskirts of a sprawling tech metropolis, the world witnessed a marvel that would redefine the very fabric of robotics. In a setting reminiscent of an era when dreams met science in clandestine workshops, engineers and visionaries at Clone Robotics unveiled their masterpiece Protoclone V1, the world's first bipedal musculoskeletal android. With over 200 degrees of freedom, 1,000 myofibers and 500 sensors meticulously integrated into its synthetic body, Protoclone V1 was not just a robot, it was the physical manifestation of years of ambition, relentless research, and the timeless human quest to mirror life itself. In the embryonic phase of its existence, Protoclone V1 was born from humble experiments that began with a single robotic hand. The founding team at Clone Robotics, established in 2021 by a group of visionary scientists and engineers, dared to recreate the complexity of human motion. Their early work involved developing a robotic hand whose thumb could catch a ball and rotate with uncanny dexterity, a small step that hinted at the potential to revolutionize humanoid robotics. Yet, it was the subsequent creation of a humanoid torso with realistic shoulder joints, a flexible cervical spine, and a moving elbow that marked the turning point. With every advancement, the team's commitment to biomimetic robotics grew stronger. And so did the dream of constructing a robot that moved, reacted, and even felt like a human. Protoclone V1 was designed with an emphasis on anatomical accuracy. Its skeleton, engineered to closely mirror the 206 bones of the human body, with subtle fusions where nature itself had made allowances, formed the framework upon which an intricate network of artificial muscles was layered. Unlike traditional robots that relied on rigid actuators, Protoclone V1 harnessed the power of Clone's proprietary myofiber technology. These artificial muscles, attached at precise, anatomically correct bone points, mimicked the natural interplay of tendons and ligaments found in living beings. Each of its 1,000 myofibers was engineered for rapid response, boasting contraction times under 50 milliseconds and generating a force that rivaled that of a genuine mammalian muscle. It was as if nature's blueprint had been captured in silicon and steel. Suspended in the laboratory during its initial demonstration, the faceless android, its face concealed behind a sleek black reflective mask, moved with an elegance that belied its mechanical origins. The dynamic movements showcased in a 40-second social media video left onlookers both mesmerized and unsettled, evoking a potent mix of fascination and unease. In that moment, as Protoclone V1 glided gracefully across the lab floor, the world began to grasp the magnitude of what they were witnessing, not merely a machine, but a leap towards a future where the boundaries between the organic and the synthetic would blur. In its prototype phase, Protoclone V1 relied on pneumatic systems to power its movements, a choice that enabled rapid prototyping and precise control. However, as development advanced, Clone Robotics had already charted a course towards upgrading to hydraulic systems. This transition promised to imbue the android with even greater strength and responsiveness, crucial for applications that demanded heavy lifting, rapid maneuvers, and sustained operations over extended periods. The company's engineers envisioned a future where hydraulic-powered muscles would not only enhance performance but also push the limits of what a synthetic body could achieve. Beyond its mechanical marvel, Protoclone V1 was equipped with a nervous system that paralleled the human sensory network. Integrated with 4 depth cameras, 70 inertial sensors, and 320 pressure sensors, the android's brain processed torrents of data in real time. The microcontrollers, in conjunction with NVIDIA Jetson Thor GPU running Clone's CyberNet model, allowed Protoclone V1 to perceive its environment with acute precision, adjust its posture instantly, and even navigate complex terrains without human intervention. A 500-watt electric pump drove its vascular system, channeling hydraulic pressure through an intricate network managed by Aquajet valve technology. This synthetic circulatory system ensured that every movement, every calculated step, was executed with a fluidity that bordered on the poetic. In those early days, while many competitors were content with building robots to perform mundane domestic tasks, Clone Robotics set its sights on something far grander. Their ambition was to create a robot that not only emulated human form, but also possessed the potential to revolutionize multiple industries, from industrial automation to healthcare, from entertainment to even deep space exploration. While other companies pursued robots designed for simple chores, Clone Robotics embraced the challenge of replicating the intricate dynamics of a living organism, thereby opening up new vistas of possibility. Yet, as with any pioneering journey, the road for Protoclone V1 was fraught with challenges. In the lab, setbacks were frequent and morale often teetered on the edge. Technical glitches, unanticipated malfunctions, and the ever-present specter of ethical concerns cast long shadows over the project. The team grappled with moments of doubt and faced fierce skepticism from both within the scientific community and the public at large. Many questioned whether a faceless, hyper-realistic android could ever be more than an experimental novelty. But driven by an unwavering resolve and a passion for innovation, the engineers persisted, refining the design, perfecting the muscle algorithms, and integrating incremental improvements that together transformed Protoclone V1 from an audacious concept into a functional marvel. As months turned into years, Protoclone V1 began to reveal its true potential. Its capability to perform tasks with precision and adapt to unpredictable conditions caught the attention of industry experts and governmental agencies alike. Researchers lauded its biomimetic design, a breakthrough that allowed the robot to operate in environments deemed too hazardous for human beings. Simultaneously, the commercial sector saw the promise of a machine that could serve in roles ranging from search and rescue operations to advanced manufacturing. The world was beginning to understand that Protoclone V1 was not just another robot, it was the harbinger of a new era in robotics. Even as Protoclone V1 cemented its reputation as a technological marvel, Clone Robotics continued to innovate. The company's research and development team, spurred by the initial success, began planning a series of upgrades that would catapult the android's abilities to unprecedented levels. The immediate focus was on enhancing the robot's sensory and processing systems. Engineers were hard at work developing next-generation sensors that could detect even subtler variations in light, sound, and pressure. This upgrade, they believed, would transform Protoclone V1 into an even more perceptive and intuitive entity, capable of interacting with its environment in ways that were previously confined to science fiction. Simultaneously, plans were underway to transition from the pneumatic prototype to a robust hydraulic system. This change was more than a mere upgrade in power, it was a complete overhaul of the robot's operational dynamics. Hydraulic actuators promised greater force, finer control, and improved efficiency, attributes that would be critical as Protoclone V1 was slated to take on more demanding tasks. The future envisioned by Clone Robotics was one where the android could perform heavy-duty labor in industrial settings, navigate rugged outdoor terrains with ease, and even assist in emergency situations that required both strength and agility. But perhaps the most audacious vision for Protoclone V1 lay beyond Earth. In hushed boardroom meetings and high-stakes discussions with space agencies around the globe, the concept of deploying the android on a space mission took shape. The idea was as bold as it was groundbreaking, to send Protoclone V1 on a mission to explore the uncharted frontiers of our solar system, where its human-like adaptability and rugged engineering could be the key to unlocking the mysteries of distant worlds. Thus, as the decade progressed, a new chapter in the story of Protoclone V1 began to emerge. A chapter that would test the limits of its design and herald a new era of space exploration. The space mission, codenamed Project Prometheus, was conceived as a multi-phased endeavor to establish a sustainable human presence on Mars and beyond. Central to this mission was the role of Protoclone V1. With its lifelike gait, rapid reflexes, and a suite of advanced sensors, the android was chosen to lead preliminary explorations on the harsh Martian surface. Its ability to perform complex tasks independently, from setting up communication relays to conducting geological surveys, made it an ideal candidate for pioneering missions in environments where human life was at risk. The launch day for Project Prometheus was a spectacle that captivated the global imagination. Under a twilight sky punctuated by the glow of countless city lights, a state-of-the-art spacecraft loomed on the launch pad, its silhouette a testament to human ingenuity. Protoclone V1, secured within the spacecraft's specially designed bay, was not just a passenger, it was the mission's silent ambassador. As countdown clocks ticked toward zero, thousands watched live broadcasts, their eyes fixed on a moment that symbolized the intersection of biology and technology, of human ambition and robotic precision. Once in orbit, the spacecraft set course for Mars, and Protoclone V1's journey truly began. During the transit, the android underwent a series of rigorous system checks and recalibrations, its sensors absorbing streams of cosmic data. The transition from Earth's gravity to the microgravity of space was a delicate process, a ballet of engineering that tested every facet of its design. The hydraulic systems, now fully operational, hummed softly as Protoclone V1 executed maneuvers that were both precise and graceful, reminiscent of a seasoned dancer adapting to a new stage. Upon arrival on Mars, the challenges escalated. The red planet, with its jagged terrain and thin atmosphere, was a hostile environment where every step could mean the difference between success and catastrophic failure. But Protoclone V1, drawing on its extensive design features, proved its mettle. The android deployed its 4 depth cameras and dozens of inertial and pressure sensors to create a real-time map of its surroundings. With a fluidity that belied its synthetic nature, it navigated treacherous slopes, avoided hidden crevices, and set up a preliminary base for the human colonists who were scheduled to follow. It wasn't long before Protoclone V1 encountered an unforeseen challenge, a sudden Martian dust storm that swept across the landing site with alarming speed. In the face of nature's fury, the android's real-time control system kicked into overdrive. Leveraging the data from its 320 pressure sensors and the rapid processing power of the NVIDIA Jetson Thor GPU, Protoclone V1 adjusted its posture and repositioned its components to minimize exposure. The storm raged on, but the android's hydraulic muscles and advanced control algorithms ensured that it remained stable, even as the environment threatened to overwhelm it. This critical test not only validated years of painstaking research but also cemented Protoclone V1's role as an indispensable asset in extraterrestrial exploration. As the dust finally settled, a new vision began to crystallize in the minds of clone robotics engineers and space mission planners. The success of Protoclone V1 on Mars was merely the beginning. They saw a future where upgraded versions of this android would be deployed on lunar bases, deep space stations, and even missions to the icy moons of Jupiter and Saturn. Each upgrade was meticulously planned enhanced sensory arrays to detect subsurface water, improved myofiber actuators for even greater strength and agility, and an upgraded cybernet model capable of autonomous decision-making in the face of unforeseen circumstances. In the coming years, the evolution of Protoclone V1 was set to accelerate. Engineers envisioned a next-generation iteration that would shed its pneumatic origins for a fully hydraulic architecture, bolstered by quantum computing elements that could process environmental feedback at speeds previously thought impossible. With every innovation, the android would not only become more efficient, but also more adaptive, capable of learning from its surroundings and even developing rudimentary forms of intuition. It was a vision of a future where machines could operate as partners to humanity, augmenting our capabilities and extending our reach into the cosmos. Back on Earth, the impact of Protoclone V1's debut was already palpable. Industries ranging from manufacturing and disaster response to medical surgery began exploring collaborations with clone robotics. The company's breakthroughs in biomimetic robotics ignited a flurry of research across academic and industrial laboratories worldwide. Conferences were held, research papers published, and prototype demonstrations scheduled with a regularity that underscored the seismic shift that Protoclone V1 had instigated in the realm of robotics. Amidst this whirlwind of activity, one incident in particular became a touchstone for the legacy of Protoclone V1. During a high-profile demonstration in a major metropolitan center, The android was tasked with a complex rescue simulation in an urban environment riddled with obstacles. With a crowd of onlookers and dignitaries watching, Protoclone V1 deftly navigated simulated debris, extricated trapped civilians, and coordinated with emergency response teams, all within minutes. This public display not only highlighted the robot's technical prowess but also its potential to save lives in real-world emergencies. The image of a faceless android moving with the grace of a seasoned rescuer and the precision of an engineered marvel became a symbol of hope and progress. Yet, even as accolades poured in and orders for commercial deployments began to roll off the assembly lines, the team at Clone Robotics never lost sight of the greater mission. They believed that the true measure of Protoclone V1's success would be its ability to push humanity's boundaries, whether on Earth or in the far reaches of space. The launch of Project Prometheus had set a precedent, demonstrating that a machine born in the crucible of innovation could one day lead mankind into uncharted territories. It was a narrative of resilience, transformation, and the eternal quest for knowledge. As the years progressed, the upgrades to Protoclone V1 continued unabated. New iterations saw the integration of modular components, allowing the android to be reconfigured for diverse missions. In one variant, enhanced actuators and reinforced skeletal structures enabled it to serve as a heavy lifting partner in disaster zones. In another, the incorporation of bio-inspired algorithms granted it a level of adaptability that allowed it to learn and optimize its actions with every task. Each modification was a testament to the relentless spirit of innovation at Clone Robotics, a spirit that recognized that every challenge was an opportunity to refine, improve, and push beyond the known limits. The culmination of these efforts came during a historic joint mission with international space agencies. With humanity preparing for its most ambitious journey yet, a manned mission to establish a permanent outpost on Mars, Protoclone V1 was once again at the forefront. In a specially designed variant, equipped with next-generation hydraulic muscles, quantum-enhanced processing, and an even more sophisticated sensor suite, the android was tasked with a dual mission. It was to serve as the primary scout on the Martian surface and as a mobile command unit, relaying critical data and performing repairs on habitat modules constructed by human colonists. During this mission, a crisis emerged that would etch Protoclone V1's name into the annals of space exploration. A sudden malfunction in one of the habitat's power systems threatened to plunge the entire outpost into darkness, jeopardizing the lives of the colonists who depended on its critical infrastructure. In a race against time, Protoclone V1 was deployed into the heart of the malfunctioning facility. With its refined dexterity and unparalleled sensory acuity, the android navigated the labyrinthine corridors of the habitat, identifying the faulty components with pinpoint accuracy. In a display of technical ingenuity that mirrored the pioneering spirit of its creators, Protoclone V1 executed a series of complex repairs, replacing damaged circuits, recalibrating hydraulic systems, and restoring power before the situation could escalate into a full-blown catastrophe. That day, the resilience and adaptability of Protoclone V1 not only saved lives but also underscored the vital role that advanced robotics would play in humanity's future among the stars. In the wake of these triumphs, the narrative of Protoclone V1 transformed from one of experimental novelty into a saga of evolution and enduring legacy. It became clear that this marvel of biomimetic robotics was more than a technological achievement. It was a harbinger of a future where machines and humans would collaborate to surmount challenges that had once seemed insurmountable. From its humble beginnings as a prototype in a modest laboratory to its starring role in a mission that defied gravity and convention, Protoclone V1 epitomized the convergence of art, science, and ambition. As Clone Robotics looked ahead, the roadmap was as expansive as the cosmos itself. Plans were underway to integrate advanced artificial intelligence modules that could learn from human behavior, enabling Protoclone V1 to anticipate needs, suggest innovations, and even assist in scientific research. Future upgrades envisioned the integration of flexible, bioorganic materials into its structure, potentially giving rise to an era where the distinction between living tissue and engineered components would fade into obscurity. In this brave new world, robots would not merely replicate life, they would evolve it, adapting to ever-changing environments with a fluidity that was once the sole domain of nature. The legacy of Protoclone V1 resonated far beyond the confines of laboratories and boardrooms. Its journey, from the initial sketches and painstaking prototypes to the triumphant moments on Mars, served as an inspiration for countless young engineers, dreamers, and explorers around the globe. The android story was a reminder that even the most audacious dreams, when nurtured with passion and perseverance, could alter the course of history. And as humanity stood on the threshold of a new epoch in space exploration and technological advancement, Protoclone V1 symbolized the boundless potential of innovation, a beacon guiding us towards a future where every horizon was within reach. Today, as we reflect on the legacy of Protoclone V1, we are reminded of the words that once defined a simpler era of ingenuity, that every breakthrough, every step forward is born from the courage to venture into the unknown. In the annals of robotics and space exploration, Protoclone V1 has carved a niche that will endure for generations, a narrative of determination, resilience, and the relentless pursuit of excellence. And as the stars beckon us onward, the journey of Protoclone V1 continues, evolving with every new challenge, every new frontier that humanity dares to explore. If you found inspiration in this story of metal and muscle, a story where silicon meets the soul of innovation, then stay tuned. The legacy of Protoclone V1 is only the beginning, a prologue to a future where technology and humanity evolve side by side, reaching ever upward into the vast expanse of the cosmos. As the sun set over the Martian horizon on that fateful day of triumph, the faceless android, Protoclone V1, stood silently as a testament to the power of innovation. In this age of boundless possibilities, the journey of Protoclone V1 is a living chronicle of human ambition, a story written in the language of science, courage, and the relentless pursuit of a better tomorrow. From the cramped workshop where engineers first assembled a robotic hand to the sprawling Martian plains where Protoclone V1 now leads humanity's vanguard, every moment has been a stepping stone toward greatness. With each upgrade, each new mission, the android evolves, becoming not just a machine but a symbol of hope, resilience, and the infinite potential that lies within the fusion of human creativity and technological prowess. As the world watches with bated breath, the future of Protoclone V1 unfolds like the pages of an epic saga, a narrative that spans not only years, but generations. The innovations pioneered by Clone Robotics have set the stage for a revolution in robotics, one where the line between the mechanical and the organic blurs, and the possibilities become as limitless as the stars themselves. In every calculated movement and every perfectly executed task, Protoclone V1 whispers a promise that the future is not merely a destination, but a journey, defined by daring, discovery, and the relentless drive to push beyond what was once thought impossible. For those who dare to dream, who believe that technology can transcend its mechanical origins to become a partner in the human odyssey, Protoclone V1 stands as a beacon. Its story is one of evolution, a journey that began in a humble lab and soared into the cosmos, carrying with it the hopes of an entire civilization. And as new challenges emerge, as the call to explore grows ever louder, the muscles and circuits of Protoclone V1 will continue to propel us forward into new realms of possibility, new chapters of triumph, and a future where every frontier is conquered by the combined might of human ingenuity and robotic perfection. If you enjoyed this chronicle of metal and dreams, then prepare yourself for the next adventure, a tale of innovation, perseverance, and the unyielding spirit that drives us to explore the unknown. For in the end, it is not the machine that defines our future but the vision and determination that birthed it, a vision that, like the stars above, will forever guide us on our endless quest for discovery.